So let's say you have the radical equation x plus 5 is equal to the square root of x plus 5. What we're going to do first is try to get rid of this radical right here. And to do that, we're going to square both sides. So we're going to have x plus 5 squared is equal to, well, if we square a radical, that cancels out the radical. So we're just going to have is equal to x plus 5. Okay. And now for our left-hand side, in order to square this binomial, we're going to use an area model. You can use FOIL if you like, but an area model works too. So x plus 5 and x plus 5. Okay, we're going to have x squared plus 5x plus 5x plus 25. Okay, so this left-hand side, x plus 5 squared, is really just x squared plus 10x plus 25. Okay, and that's equal to x plus 5. What we're going to do next is move all these to the left-hand side. Okay, so when you subtract the x from both sides, you're going to get x squared plus 9x plus 25. And when you subtract this 5 from the 25, you're going to get x squared plus 9x plus 20. Okay, and that's equal to 0. Okay, now we just have a quadratic. So to solve this quadratic, we have two main options. We can either factor or use the quadratic formula. I'll be factoring for this one. Okay, so when we factor, we want to find what adds to 9, so adds, and what multiplies to 20. After cycling through a few numbers, you should see that it's 5 and 4. Because 5 plus 4 is 9, and 5 times 4 is 20. So that means we can write this quadratic as x plus 5 times x plus 4. Okay, and that's equal to 0. Okay, and if we set either one of these equal to 0, this is going to result in 0. So that means this is negative 5 and negative 4. Because if you plug in negative 5, you're just going to get 0 times negative 1, and it's 0. Okay, so these are solutions. X is equal to negative 5 and negative 4. But what we have to do with these radical equations is we have to check our solutions, because sometimes we have extraneous solutions, which is just fake solutions. Okay, so let's plug these back in to make sure they work. Okay, plugging in negative 5, that's 0 equals 0, so that's true. Now let's plug in negative 4, this equation. We're going to have 1 is equal to the square root of 1, which is also true. Okay, so that confirms that we have no extraneous solutions, and we're done.